Now we see about isotopes, isobars and isostones, isosters, so etc. So before knowing about isotopes, isobars and remaining, we must know about atomic number and mass number. So what is atomic number? So at first the atomic number concept was introduced by Mosley with the help of his experiment on the elements. His experiment on the elements is the passing of cathode rays. So there is a very nearly 60 to 70 elements are present when Mosley done his experiment. He tested all elements. He tested all elements in his experiment. So what was that experiment is? He passed the cathode rays through the elements and he observed all elements released. Here all elements emitted X-rays. All elements, not only one element, whatever the elements discovered at the time, all elements emitted X-rays in his experiment. But what is the difference is, the frequency of X-rays emitted by all elements, they are not identical. Means all elements emitted X-rays are having different frequencies. Different frequencies means they are having different wavelengths. He did the same experiment with all elements, and all elements emitted X-rays, but the frequency are nothing but otherwise wavelength of the X-rays are totally different. అంటే ఒక ఎలిమెంట్ నుంచి రిలీజ్ అయిన ఎక్స్రే ఫ్రీక్వెన్సీ ఇంకో ఎలిమెంట్కి వచ్చిన ఎక్స్రేస్ ఫ్రీక్వెన్సీ దేంతో మ్యాచ్ అవ్వట్లేదు. అంటే ఎన్ని ఎలిమెంట్స్కి ఎక్స్పెరిమెంట్ చేశాడో అన్ని డిఫరెంట్ ఫ్రీక్వెన్సీస్, అన్ని డిఫరెంట్ వేవ్ లెంగ్త్స్ ఆఫ్ ఎక్స్రేస్ హీ అబ్టైన్డ్. అండ్ విత్ ద హెల్ప్ ఆఫ్ దిస్ frequency and wavelength, he was able to calculate the charge on the nucleus of atoms of different elements. And by all these conclusions, by all these observations, experimental observations, he concluded that the atomic number, so nothing but the number of positive unit charges, the number of unit positive charges are the basic fundamental property for elements, or nothing but for atoms. Means till he introduced the atomic number concept, every scientist in the world followed the atomic weight concept. So according to the other scientists, the total physical and chemical properties of elements are totally due to their atomic weight. But the first time Mosley, just at the age of 25 years, a young scientist, he totally opposed that concept in which everyone followed that atomic weight is the main property of elements. That is the more fundamental property of the elements. So with the help of his experiment and by calculating the charge on the nucleus of atoms of all different elements, he was able to calculate the charge on the nucleus, and with the results of this experiment he concluded that the number of unit positive charges, the number of unit positive charges number of unit positive charges in an atom are are nothing but the main fundamental property for atoms, nothing but the properties of that elements. He also given an equation which explains his concept, which is known as Moseley's equation. Now we see that equation. The Moseley's equation is root nu. This is called as nu, which indicates the frequency of the any rays. But here it is the frequency of X-rays emitted by the elements in Moseley's experiment. Root nu is equal A into Z minus B. Here nu is equal to characteristic frequency of X-rays emitted by elements in his experiment. So A comma B are generally they called as Moseley's constants. So these constant values are that depends on nature of element. And the ఒక్కొక్క element ki A comma B values different content. They are constant for a fixed element. Next, Z is equal to number of unit positive charges that was treated as number of protons, and that is given as atomic number. So simply we can say, so what is the atomic number? The number of unit positive charges present in an atom. Nothing but simply the number of protons. The number of protons nothing but is equal to the atomic number. So what we can say now? So what is atomic number? So atomic number means the number of protons present in the nucleus of that atom. Okay. So this is called Moseley's equation. Now we know the atomic number. So what is the atomic number? Atomic number is called indicated with denoted with Z is equal to number of protons in the nucleus of an atom. Atom is always neutral. We know that always atom is neutral. Therefore, the positive charge must be equal to the negative charge, and the negative charge must be equal to the positive charge. Therefore, in the place of number of protons, we can write number of electrons. But when you say about the number of electrons, we must use the word the number of electrons in a neutral atom, because there is a possibility of losing of electrons or gaining of electrons, forming positive ion and negative ion. So the atomic number is equal to number of electrons only when atom is present in its neutral form. The number of protons, so there is generally no losing and no losing of or there is no gaining of protons. So therefore the number of protons in an atom we can say directly, but in the number of electrons when compared to the atomic number we must mention the any neutral atom. Next is the mass number. With the help of different theories, we know that the mass of the atom is totally concentrated in the center of the atom. We know that the total mass of the atom is concentrated at the center of the atom. The center of the atom is known as, we know that it is nucleus, and nucleus is consists of protons and neutrons. Means so it is given that the mass number is nothing but the total mass of the atom is only due to this mass of protons and this mass of neutrons. Therefore, the number of protons and the number of neutrons is considered as mass number. Then what about these electrons? In an atom, there is also electrons are present which are exactly equal to the number of protons. But we know that the charge of electrons, the mass of electrons is negligible. So that's why in the calculation of mass number, we simply neglected the mass of these electrons. Means mass number not exactly gives the accurate value of mass of that atom. We are totally neglecting the mass of electrons. Now what is the mass number? It is equal to number of protons plus number of neutrons. So neutrons, protons are present in the nucleus. That's why the particles are also treated as nucleons. So what is the mass number now? That is we can say number of nucleons or the number of protons plus number of neutrons. So this is mass number. So this is atomic number. So in the variation in the atomic number and mass number, we discuss about the isotopes and isobars and remaining. Okay. So next we see the isotopes. So isotopes means that the atoms of an element. We must remember atoms of an element. There is no change in the element. The atoms are different. The atoms of an element. So atoms of an element means automatically they are having same atomic number, but they differ in their mass number. So simply we can define that the atoms of an element with the same atomic number having different mass number are called isotopes. So how it is possible for atoms of an element differ in their mass numbers? All we know, for any elements, the atoms of any element having same number of atomic number, nothing but same number of protons. But how they are having the different mass numbers? Mass number means number of protons and number of neutrons. They belong to same element means they are having same number of protons. But what is the difference now? They are having different number of electrons. That's why their mass number is different. Here, differ in mass number, it happens due to the differing in the number of neutrons. అంటే ఆటమ్స్లో ఉన్న నెంబర్ ఆఫ్ న్యూట్రాన్ అటామిక్ నెంబర్ సేమ్ ఉంది కాబట్టి నెంబర్ ఆఫ్ ప్రోటాన్స్ ఆల్రెడీ దే ఆర్ సేమ్, బట్ నెంబర్ ఆఫ్ న్యూట్రాన్స్ డిఫరెన్స్ ఉన్నాయి కాబట్టి దాని మాస్ నెంబర్లో డిఫరెంట్ వచ్చింది. సో ద ఆటమ్స్ which are differ, the atoms of an element which are differ in the number of neutrons, or atoms of an element with same atomic number but differ in their mass number are called as isotopes. Now we see some examples. Isotopes of hydrogen H11 is called protium, H12 is called as deuterium, H13 is called like tritium. So these three are isotopes of hydrogen, in which all are having same atomic number, means they are all having same number of protons, 1 1 1, but they are different in their number of neutrons. Here we are having number of neutrons 1 minus 1 equals 0 here. So what is the number of neutrons here? 2 minus 1 equals to 1 neutron. Here the number of neutrons is 3 minus 1 equals to 2. Means they are having same number of protons, but they are having different number of neutrons. That's why they got different mass numbers. So these are isotopes of hydrogen. Now we see the other isotopes. There is C612 is there, C613, C614. These are isotopes of carbon. And see uranium 92, 234, uranium 92, 235, and even there is a presence of uranium 92, 238. So majorly, if you take an uranium sample, it consists of uranium 92 and 235. Very less fractions, nothing but 0.005, less than 0.1%. There is a presence of uranium 92, 234. But these three are treated as isotopes of uranium, which are having same 92 atomic number. Their mass numbers are different. Why they are having different mass numbers? Because they are having different number of neutrons. Now see some important properties of isotopes. As we know that isotopes are having same number of protons and same number of electrons. As they are having same number of protons, they are having similar chemical properties. But as they are having different mass, as they are having different mass number, they may have different physical properties. Here important one, they are having similar chemical properties because they are having same number of proton, and one of the other reasons is same number of electrons and same electronic configuration. But even they are having similar chemical properties, they are different their chemical reactivity speed. అంటే isotopes for example hydrogen isotopes లో H11 and the speed గా H12 reaction speed కావాలి. H13 చూస్తే that is total radioactive, అంటే the reactions మనం కంపేర్ చేయలేము అసలు. Means they are having same chemical properties, but the speed of that chemical reaction maybe varies. Okay, so this is about isotopes. Next we see the isobars. Next we see the isobars. So isobars means here the atoms of different elements. Hey, important thing, atoms of different elements. So atoms of different elements means it is compulsory they are having different atomic number. The atoms of different elements with the different atomic numbers. As we said, they are belongs to different elements, so they must have different atomic number. So what is the similarity in them? They are having same mass number. So they are having different atomic number and same mass number. So we can say it is exactly reciprocal to the isotopes. Whereas in isotopes it was a same atomic number, different mass number. But here exactly reciprocal to it. It is having different atomic number and same mass numbers. The atoms which are having different atomic number with the same mass number are treated as that are called isobars. Now we see some examples. So as they are having different atomic numbers, they consist of different number of protons. They consist of different number. It is compulsory. So they are having different atomic number means they are having different number of protons. But how they become same number of mass number? ఇప్పుడు డిఫరెంట్ ఆటమ్స్ ఉన్నప్పుడు కంపల్సరీగా నెంబర్ ఆఫ్ ప్రోటాన్స్ ఉంటాయి. సో నెంబర్ ఆఫ్ ప్రోటాన్స్ డిఫరెన్స్గా ఉన్నాయంటే మాస్ నెంబర్ ఈక్వల్ చేసి ఎప్పుడు వస్తుంది? అగైన్ దెర్ ఈస్ ఎ డిఫరెన్స్ ఇన్ ద నెంబర్ ఆఫ్ ప్రోటాన్స్. అంటే ఇక్కడ వాటిలో ఉన్న నెంబర్ ఆఫ్ ప్రోటాన్స్, నెంబర్ ఆఫ్ న్యూట్రాన్స్ టోటల్ డిఫరెంట్ ఉన్నాయి. బట్ ఇఫ్ యూ సమ్ దెమ్ ద టోటల్ ఆఫ్ దట్ నెంబర్ ఆఫ్ న్యూట్రాన్స్ అండ్ ప్రోటాన్స్ యాడ్ చేస్తే వచ్చే సమ్ వాల్యూ మాస్ నెంబర్ మాత్రం ఈక్వల్గా ఉంది. మీన్స్ they are not at all having same number of electrons and same number of protons. So simply we can say they are having total different chemical properties. As they are having same mass number, they may have similar physical properties. We see some examples. So this is one of the best examples. The potassium 1940, calcium 2040. Here they are having atomic numbers. They are having atomic numbers 19, 20. Nothing but the number of protons is 1920. But what is the number of neutrons? What is the number of neutrons in it? The 40 minus 19. 29. Here, what is the number of neutrons here? The 40 minus 20. Here, 20. So here total its mass number becomes 40. Its mass number becomes 40. Means they are having total different number of protons, different number of neutrons, but some of them is becomes equal. So now we can say potassium 1940, calcium 2040 are best examples for isobars. See other examples. Say C614 and 714. So argon 1840, potassium 1940, calcium 2040. So this is also another combination of examples of isobars. Okay, we need to compare the isotopes and isobars. That's the important one. Next we see the isotones. Here isotones means the atoms of different elements. Here again we need to give important difference of the atoms of different elements, mean they must contain different number of protons, and nothing but they are having different number of atomic number, and they also so the atoms of different elements with different atomic number, different mass number. Then what is the similarity? They are having same number of neutrons. The atoms of different elements, simply we can say the atoms of different elements having same number of neutrons are known as isotones. For example, if you see the examples of isotones, sulfur 1632, chlorine, sulfur 16, there is also presence of 36, 37, argon 1838, potassium 1939, calcium 2040. So this group of elements is best example of isotones. See here, what is the number of atomic number or different, means they are having total different number of protons. They are having different mass numbers. But what is the similarity in them? The number of neutrons present in them is similar. Here 36 minus 16, the number of neutrons equal to here 20. So 20, 20, 20, 20. So all are having same number of neutrons. So this group of examples is the best example for isotones. And we can't compare the chemical properties and physical properties just like in already we can compare the chemical and physical properties in isotopes and isobars. But here we can't compare the physical and chemical properties of these isotones. And next we see the other example. So this group of atoms are also best example for isotones. Here the number of electron, the number of neutrons is how much? 16. Neutrons 16, neutrons 16. So this group is also one of the best example for isotones. Okay. Next we see the next one. Isodiaphers. So isodiaphers means the atoms which are having same isotopic number. Here important is what is isotopic number. It is not like that number of electrons, number of protons and number of neutrons. So this is not a basic property of an atom. It is a physical number. It is a physical quantity of an atom which is obtained by a formula that is n minus p. Means the number of neutrons minus protons, or it is nothing but equal to a minus 2z mass number minus 2 into atomic number. So this number value, the physical value is known as isotopic number. If two atoms are having same isotopic number, they are treated as isodiaphers. I have very rare examples of it. See the examples. Thorium 90-234 and uranium 90-238. Now what is the N minus P value? What is N minus P value? So N means the number of neutrons. So how many neutrons are present in it? 234 minus 90. Sorry. This is N value. Next, what is the number of protons? Minus 90. Okay, number of neutrons minus number of protons. For example, if you do the A value, if you do this type of formula, A means 234 minus 2Z. Z means here 90. That is equal to 2 into 90, that is 180. What is our total value? 54. So again here 238. What is N minus P value for it? N minus P. Neutrons means 238 minus 92. Again minus Z. Nothing but P. 92. It is also gives so value 54. So this isotopic number is equal for these two atoms. So they are best example for isodiaphers. Here also we can compare any physical and chemical properties. So next we see the other one. Okay. Isotopes. So isotopes means so it is totally different from the isotopes and isobars, isotones and isodiaphers. So that all properties, that all concepts belong to the atoms. Whereas this isotopes topic, nothing but this concepts belongs to the molecules. Here we can say what are isotopes means the molecules. The molecules having same number of atoms and they are also having same number of electrons. So the group of molecules which are having same number of atoms and the same number of electrons, so are known as isotopes. So for example, CO2 and N2. If you take one particular molecule of a CO2, it contains how many atoms? One carbon, one oxygen, totally 3 atoms. If you take particular one molecule. Here also one nitrogen, second nitrogen, oxygen. It is also having 3 atoms. They are having same number of atoms. Now, see what is the total number of electrons in that particular molecule. Carbon is having how many electrons? 6. One oxygen 8. This 8. So how many electrons now? That is 22 electrons. Now, what about the number of electrons in this example? having 7 electrons, 8 electrons, total 22 electrons. So these are all treated as isotopes. The molecules having same number of atoms and same number of electrons in it, they called as isotopes. And the last but one is isoelectronic. Is isoelectronic ions. That means iso means nothing but there is something is equal. Then only we use the word iso. Here, what is the same? Electronic ions means the ions having same number of electrons are known as isoelectronic ions. For example, helium plus, how many electrons are there? 1 electron. Lithium plus 2, how many electrons? 1 electron. So beryllium plus 3, how many electrons? 1 electron. So these ions are that were treated as isoelectronic ions. And there is also a group of ions which are best examples. N minus 3, O minus 2, F minus, Na plus, Mg plus 2, Al plus 3, Si plus 4. So they are totally belongs to different elements and their charge is also totally different. Nothing is equal in them. But what is the equal in them? What is the similarity in them? The number of electrons. N minus 3 means in normally nitrogen having 7 electrons. Obtaining minus 3 charge means after getting 3 electrons you become 10 electrons. Similarly all are having 10 electrons. So these are called isoelectronic ions. The series of these isoelectronic ions when arranged in the increasing order of their atomic number. So ఇక్కడ మనం అరేంజ్ చేసినట్లు ఇక్కడ atomic numbers one by one increase చేస్తుంది. And this series can be known as isoelectronic series. The series of ions having same number of electrons arranged in the increasing order of their atomic number. This series is called isoelectronic series. So this is about the general properties of atoms. Okay.